After studying this module, you shall be able to learn about the essential trace and toxic elements known to us and role played by them, identify the criteria for an element to play an essential role in our body, know about the essential ultra-trace metals and non-metals with their examples, know about the toxicity and deficiency of different elements known to us, identify the toxic effects of various trace elements in detail. Of the 109 known elements, 30 elements are believed to be essential for the survival of the living organisms. 19 of these 30 are trace elements, out of which 12 are transition metals. We can account for the biological activity of about one half of the essential trace elements which function in metalloenzymes, including iron, zinc, copper, manganese, molybdenum, cobalt, nickel and selenium. As shown in figure, these shows the essential element in the periodic table. Purple one shows the essential elements for human, for example sodium, magnesium, phosphorus, chlorine. Then the grey one are the non-essential for humans. All the elements which are shown in grey color are non-essential for human, and the one in green, they are suggested to be essential for human, for example nickel, chromium, arsenic, tin and so on. Knowledge of the biological function of the trace elements has lagged far behind. The treatment of anemia with iron and the association of iodine deficiency with goiter mark these as the only two trace elements recognized as essential for animals. In an early 20th century, discovery of the essentiality of the copper, zinc, cobalt, manganese and molybdenum in animals were the main thrust. These efforts have resulted in evidence supporting the essentiality of selenium, chromium, tin, vanadium, fluorine, silicon, nickel, lead, cadmium, arsenic and lithium. What are the criteria for essential elements? The criteria for an element to play an essential role in our body are as follows. A physiological deficiency appears when the element is removed from a purified diet. The deficiency can be relieved by the addition of one specific element. A specific biochemical function is associated with a particular element. The simplest definition of an essential element is, it is an element required for the maintenance of life. Its absence results in death or a severe malfunction of the organism. This rigorous criteria cannot always be satisfied, and this has led to a broader definition of essentiality. An element is considered essential when a deficient intake produces an impairment of function and when restoration of physiological levels of that element relieved the impaired function or prevents impairment. The organisms can neither grow nor complete its life cycle without the element in question. The element should have a direct influence on the organism and be involved in its metabolism. The effect of an essential element cannot be wholly replaced by any other element. The essential trace elements provide a classic example of required nutrients. An organism passes through several stages as the concentration of essential nutrient progresses from deficiency to excess. In absolute deficiency, death may occur. Essential ultra-trace elements. The essential ultra-trace elements are required for growth and survival of cells and organisms. They normally occur and function in cells at extremely low concentrations, usually far less than 1 micromolar and as low as 10 raised to the power 8 to 10 raised to the power minus 9 molar. The essential ultra-trace metals, of the essential ultra-trace metals, only 4, that is manganese, molybdenum, cobalt and nickel, have been clearly identified as forming metalloenzymes. Manganese metalloenzymes are present for several important enzymes: superoxidase dismutase, arginase, pyruvate carboxylase and glycosyl transferase. In molybdometalloenzymes, the metal exists as a molybdenum cofactor, a complex of the metal with a novel organic molecule called molybdotrine. The role of cobalt is the best understood of any of the essential ultra-trace metals. Both vitamin B12 and coenzyme B12 have a cobalt ion complexed in their equatorial positions by 4 nitrogens of a macrocyclic ligand called corin. Corin structure is shown in figure. Cobalt ion is present in this coenzyme B12, which is bonded with 4 nitrogens atom. The essential ultra-trace nonmetals. The essential nonmetals comprise a much more heterogeneous group than do the transition metals, whose properties are all closely related. The two essential halogens, fluoride and iodide. The two essential halogens, fluorine and iodine, are highly specific and very different. Fluoride has a remarkable antidental carries effect. This may be related to its ability to replace hydroxide, thereby stabilizing the structural matrix of bones and teeth. Fluoride also can inhibit strongly certain key enzymes, enolase, pyrophosphatase. Among the non-metals, the most important is selenium. Despite its high toxicity, selenium has been shown to be a component of several enzymes involved in essential oxidation reduction reactions. Toxicity and deficiency. Most of the essential elements are also toxic when taken in excess. Too much of copper causes necrotic hepatitis and hemolytic anemia. Selenium is the most toxic of the essential elements, and intakes greater than 4 microgram per gram is serious. Too much manganese causes psychic and neurological disorders. The dual action of trace elements in relation to toxicity and deficiency is represented by a dose response curve, which is shown in figure. The cutoff points between deficiency, normal health and toxicity vary from nutrients and from person to person. Both insufficient and an excess of iodine produces thyroid problem. Deficiency of copper and selenium may contribute to kwashiorkor. Deficiency in cobalt, a component of vitamin B12, can lead to anemia. As shown in figure, this is the dose response range of an essential element. As you can see, if the dose is very less or very high, it leads to death. There would be deficiency if dose is less than to a marginal amount, and there would be toxicity if it is more than the optimal amount. So the nature of the chemical form of an element influences the dose response relationship. For example, the cation tin 2+ and nickel 2+ are not particularly toxic. The chemical species trimethyltinion and the tetracobalt tetracarbonyl nickel are dangerously toxic. In these cases, the toxicity is due to the whole species, not just the trace element. In the case of tetracarbonyl nickel, the toxicity arises from the dissociation of the carbonyl groups. The chromium 6+ is more toxic than chromium 3, which is due to its strong oxidizing properties. Toxic effect of trace elements. Lead. Lead is so widespread in our society, it is probably the most serious toxic metal. Around 70% to 90% of the lead assimilated goes into the bones. The next major accumulator is the liver, then the kidneys. Divalent lead readily replaces calcium in bone and either becomes firmly fixed or reversibly fixed. Lead in the latter form may be released into the bloodstream, and a person who has been purged of lead may have a reoccurrence of lead poisoning at a later date to release from bone tissue. Symptoms of lead poisoning are many and not always the same for every person. The principal danger areas are the hemopoietic system, leading to anemia, the nervous system, leading to irreversible brain damage, and the renal system. Young children are particularly susceptible. The damage showing up in the behavioral and educational abnormalities and maybe mental retardation. Arsenic. Arsenic has similar toxic properties to lead, mercury and cadmium as regards bonding to sulfur and inhibiting enzyme action such as pyruvate dehydrogenase. Arsenic, which is mainly found in the livers, kidney, lungs and intestinal walls, is readily absorbed if water soluble. Since phosphorus and arsenic are in the same periodic group, and since phosphorus is a major essential element, it is not surprising that the arsenic interferes with phosphorus metabolism. Thus, arsenic is toxic by replacement of phosphorus in ATP and in coagulation of protein. This can be seen in figure. Arsenic poisoning can lead to so many problems like skin damages, it can lead to scaling skin, pigment changes, it can lead to increased cancer risk, for example lung cancer, bladder cancer, kidney and liver cancer, nerve damage, circulatory problems in skin and so on. Cadmium. Cadmium in lower levels has an adverse effect on human beings. Tobacco contains around 1 microgram per gram of cadmium. So up to 2 to 4 microgram of metals are inhaled from smoking one packet. Approximately 25 to 50% of inhaled cadmium is absorbed into the body, while from food the absorption is about 6%. A lethal dose of cadmium is more than 350 microgram. Cadmium accumulates in the liver and kidneys, produces irreversible kidney damage. Respiratory and pulmonary damage is reported to occur from the breathing of cadmium vapor or particulates. Cadmium cannot cross the placental membrane and the mammary gland is an effective barrier, so it does not affect the central nervous system. Therefore, newborn babies are quite free of any cadmium. When essential amount of cadmium are ingested, it replaces zinc at key enzymatic sites, bringing about metabolic disorders. Mercury. Mercury is the most toxic heavy metal and many serious incidences have resulted from mercury poisoning. The toxicity of mercury is related to the chemical form. Liquid mercury appears to have little effect, but mercury vapor is readily absorbed into the bloodstream, producing brain damage. In figure, symptoms of mercury poisoning are shown. These are some of the signs and symbols of mercury poisoning like irritability, shyness, tremors, change in hearing, memory problem, depression, numbness in hand, feet or around mouth. Mercury as a toxic metal came to the limelight after the incidence of Minamata disease in 1953 to 60 in Japan. Nearly 111 cases of mercury poisoning were reported among persons who had eaten mercury contaminated fish from Minamata Bay. Among them, around 45 people died. Genetic defects has been observed in 20 babies whose mother had eaten seafood from the bay. Elemental mercury has been fairly inert and non-toxic. If it is swallowed, it gets excreted without causing serious damage. Mercury vapors when inhaled enters the brain through the bloodstream, giving rise to severe damage of the central nervous system. Alkyl mercurials are even more dangerous. Copper. Copper is essential for all forms of life. Problem arise when it is deficient or in excess. In some respects, intake of essential element is more critical than for the toxic elements. The daily human consumption of copper is about 2 to 5 microgram, while the required amount for a child is to 1 to 1.6 mg per day and for adult 2 mg per day, while less than 0.3 mg per day produces deficiency. Copper is mainly distributed in the liver, kidneys and intestines. Copper deficiency means reduced protein and enzyme activity. Signs of this are anemia, loss of hair pigment, reduced growth and reduced arterial elasticity. Menkes kinky hair disease in children is due to the deficiency of cytochrome oxidase and is fatal by the age of 3 to 5 years. Wilson disease occurs with excess of copper, where the biosynthesis of ceruloplasmin is suppressed. It is an inherited disease. Zinc. The element zinc occurs in over 80 proteins and enzymes, mainly peptidases and anhydrases. The metallothioneins are zinc storage protein which are useful in combating cadmium and lead poisoning. The common problem with zinc is having a deficiency. A daily consumption of less than 5 microgram will produce deficiency symptoms such as dwarfism, dermatitis, loss of taste, immature gonads and delayed wound healing. All these are shown in figure. So these are the effects of deficiency and excess of zinc. Due to the deficiency of zinc, it affects the brain like it decreases nerve conduction, mental lethargy and so on. It affects skin like it decreases wound healing, skin lesions, reproductive system is affected, and due to the excess of zinc, brain again get lethargy and local neuronal deficits. Respiratory tracts get issues, get issues with gastrointestinal tract, prostate and so on. Summary. Of the 109 known elements, 30 elements are believed to be essential for the survival of living organisms. We can account for the biological activity of about one half of the essential trace elements, which function in the metalloenzymes including iron, zinc, copper, manganese, molybdenum, cobalt, nickel and selenium. The simplest definition of an essential element is that it is an element required for the maintenance of life. Its absence result in death or a severe malfunction of the organism. The essential ultra-trace elements are required for growth and survival of cells and organisms. They normally occur and function in cells at extremely low concentration, usually far less than 1 micromolar and as low as 10 raised to the power minus 8 to 10 raised to the power minus 9 molar. Most of the essential elements are also toxic when taken in excess. Too much of copper causes necrotic hepatitis and hemolytic anemia. The nature of the chemical form of an element influences the dose-response relationship. Arsenic has similar toxic properties to lead, mercury and cadmium as regards bonding to sulfur and inhibiting enzymes action such as pyruvate dehydrogenase. Tobacco contains around 1 microgram per gram of cadmium. So, up to 2 to 4 microgram of metals are inhaled from smoking just one packet. Liquid mercury appears to have little effect, but mercury vapor is readily absorbed into the bloodstream, producing brain damage. Alkyl mercurials are even more dangerous. Wilson disease occurs with excess copper, where the biosynthesis of ceruloplasmin is suppressed and it is an inherited disease. Daily consumption of less than 5 microgram of zinc will produce deficiency symptoms such as dwarfism, dermatitis, loss of taste, immature gonads and delayed wound healing.